when you run this last piece of code, it puts the end outcome of this entire code into an Excel file directly into your Google Drive in this specific path that you've mentioned here. And this is how the end result would look like in an Excel file. You have all the stocks in the Nifty universe and their momentum and smoothness alongside. And you can use these indicators to define your own portfolio of your own size. Please do not consider this as an investment or trading advice. Please do your own analysis and research independently before you make a sound decision. Hi everyone, this is Mani Deepak. In this session, I'm going to talk to you about how to build a momentum portfolio using Python. Well, we received some requests around how to automate the process of stock selection using any programming language. So I believe this is going to be useful for you. But before we get there, let's start with a very basic question. And I think it's important to understand why do you want to build a portfolio using Python or any programming language for that matter. Now, I would urge each one of you to start thinking about it. Well, you can build this manually, but using code, you can save a lot of time. And when you actually do this manually, and I'm going to show that to you as to how difficult it's going to be for you to implement this in Google Sheets or TradingView, for example, versus using Python or any programming language. So the first and foremost, it's going to save a lot of time for you, and I believe DIY investor is leading a busy life. So having a skill of this sort will definitely going to help you. Then number two is when you tweak some of these rules in your strategy as you evolve, as you understand more about momentum or any other strategy, or you want to couple this with something else. Tweaking the strategy means a lot of work for you if you have done this manually. Whereas it could be a small change in your code if you are using a programming language to derive those stocks. Number three would be, I would say, if you are going eventually towards machine learning or data science to improve your algorithm when you pick your stocks, I think Python is going to be very useful. Or even R as a programming language is going to be very useful. And unless you have access to special tools, I don't think you can implement a machine learning model very easily. And lastly, I think it gives you immense satisfaction and achievement when you write your own code, you see the results, you feel happy about it. So I think that fulfillment is what you gain when you write your Python code and you stick to the rules by using that code. So what are the prerequisites for the session? What do you need to already know if you had to learn with me on how to use Python to build your portfolio? Well, I don't think you need to be an expert in Python to understand what we are doing here. I'll try to make sure that I explain each and every line as clear as possible. And this session, by the way, is designed for Python beginners. So I expect as long as you can think logically, you should be able to understand the code. And I would recommend the best way to learn along the way is to, on the side, as you watch the video, you run the code, you implement it yourself simultaneously, and you can then understand or follow very clearly. And to be honest, I wrote a very basic code. It's not optimized because we are going to we are designing this for beginners. Now, If you are an expert, you can run this video at 1.5x or 2x, um, and you still want to learn. Of course, you can watch it at a higher speed than what you're seeing right now. Now let's define a strategy that we will follow today to implement through code like Python. Um, for this session, I'm using a reference guide, which is a book called Quantitative Momentum, a practitioner's guide to building a momentum-based stock selection system, authored by Wesley and Jack. So this is one of the references that I read long time ago. So there are two key metrics or indicators that are defined in this book. One is momentum itself, and the second is to understand the quality of that momentum. And the way that is defined is, I think by now you understand what momentum is. Let me just define quality of momentum for you. It's basically trying to understand if there are primarily sudden spikes in your prices that are showing up as high in momentum, but they are truly not. So the quality of momentum actually helps you understand, well, you have the momentum, but um, that's not good enough. The quality of momentum helps you understand if the price is increasing consistently, or if it is just sudden spikes in your price that is leading you to higher momentum score. So, um, well, we don't exactly mimic the formula, but we're going to use the roughly the ideas in this book to define momentum and quality. Um, and by the way, I just want to make it very clear that whatever momentum strategy that was shared with you in the other videos in our channel is not same as what is defined in this book. So we follow a different idea. For the purpose of this session, we want to keep it simple. So we're going to go with these two indicators too. Now, I just want to start with how to implement this manually. So I will, to begin with, will try to implement this on Google Sheets. That way you kind of appreciate what it takes to do this manually. And then it also helps us understand whether the code that we write later is giving the same result as what we get manually. So it definitely helps us validate the result and also compare um, the effort it takes to do this through Google Sheets or any other manual process versus writing a code. Okay, so let's take an example. If Tata Motors is one of the stocks that we want to try to understand what is the momentum and smoothness, how are we going to calculate this in Google Sheets? So let's try to do this manually, and then later we will compare this with what is coming from the code. So how do you do this in Google Sheets? So Google Sheets has this function called Google Finance. So you open that formula. The ticker here is Tata Motors, so you can select A2. And the attribute that we are looking for is price. Momentum is measured purely based on price movement, so price is the attribute. Start date, we can straight away use today as a function to get today's date minus 52 into 7. So we're going 52 weeks back in time. And from then up until 4 weeks ago. So that's the time period for which we are trying to get the momentum scores and also the smoothness scores. So as you see here, my start date is going 52 weeks back in time. My end date is going 4 weeks back in time. So essentially about 11 months roughly is what we are considering. And we want to get weekly scores, weekly stock prices. So essentially we're going to get Friday end of the day prices for Tata Motors for every week. So let's see how this runs. So here you can see from 26th May 2023 up until 19th April 2024, you have the Friday share prices for every week. Now, let's use these scores to understand the momentum and smoothness. Now, the way we calculate this as per the book that I have mentioned before is you first skip the 4 weeks. I'll tell you why. Then you would calculate the change in stock price, the percentage change in stock price. So B8 minus B4 by B4. So that gives you the stock price, change in stock price. But one thing that we need to do is for us to calculate momentum, we'll multiply all the changes in stock prices. So for us to do that product, we have to add 1 to this change. So I'm going to replicate this formula throughout. So now we've got the change in prices plus 1. Let me just call this momentum. I'm going to eventually get a summary of all of these scores. So here you see that I've added 1 to the change in the stock price. And as you can see, we are trying to get the change in the price from the existing week to the week that is 4 weeks ago. So essentially, or roughly, we can say we're getting monthly scores every week or monthly changes every week. The way we are going to get or calculate momentum is we're going to multiply all of these numbers. And that's exactly the reason we've added plus 1 to the change in percentage change in scores so that we can multiply them and we deduct 1 from the eventual score. So that's the momentum score for Tata Motors. Now, similarly, let's try to also calculate smoothness. And for smoothness, you need not consider monthly scores. You can look at the change in stock price for every week. So I'm going to replicate this formula throughout again. Now, once we get the change in weekly scores, the way we're going to measure smoothness is first we will calculate what are the number of positive changes throughout and divided by total number of weeks that we have here. So the way we're going to calculate that is we'll use the function called COUNTIF. COUNTIF essentially counts for a specific logic that we're going to give here. Here the range is D5 to D50 and my criterion is the number of positives or whether it is positive or not. So there are total 32 positive weeks for Tata Motors and I'm also going to get the total number of weeks, which is here I'm going to use a function called COUNT-A to just measure the number of weeks or measure the number of numbers that we have here, so which is 46. So 32 is the total number of positives and 46 is the total number of weeks. So now the way I'm going to measure smoothness is 32 upon 46. So 0.7 is the smoothness for Tata Motors. So now that we have these scores for Tata Motors calculated manually, let's see how can we do this in Python. Okay, so for you to write the code, you need to have a setup. You need to have an environment where you can write the code. Now, there are different ways to do that. You have something called IDEs, integrated development environments, that you can install and start writing your code. So a few examples could be Spider, PyCharm, VS Code. So you can use these tools to write your code locally in your laptop or systems. There are also online IDEs that you can use. There are also Jupyter notebooks there where you can write your code. You can install them on your systems, or you can also spin an online setup for Jupyter notebook. But what I would prefer personally is a platform called Google Colab. Google Colab is an advantage for me in some sense because I can consider data that is available in my Google Drive as an input to my code, and I can enable that easily in Google Colab. I can also produce the results and publish them in my Google Drive, since the drive is integrated with Google Colab. And the assumption that making here is that almost every one of us have a Google account. So you can easily set up a Google Colab account, um, and start writing the code. And I'm going to show how easy it is for you if you already have a Google account. Okay, so all you need to do is open this website called collab.research.google.com. And if you already have a Google account, then you can see a screen like this. And you have an option called a new notebook, adding a new notebook here. You can just click on it and it just creates a new notebook for you. And you can also rename this notebook. Right now it doesn't have any name, or it is named Untitled One. So let me name it as Momentum Demo. And all the Python notebooks will usually have this extension IPYNB, basically saying that this is a Python notebook. So this is as simple as that. As long as you have a browser and a Google account, you can set up Google Colab and you can start coding. Now, let me explain the elements here. So there are two elements here, code and text. So either you can add a code cell or a text cell. Let's try adding a text cell. So what is a text cell? So if you want to make your code reproducible, essentially what that means is if you want to revisit your code again later in time, if you want to understand the code really well, you want to share this code with someone else, then you want to give a very clear commentary on your code. So this is markdown text. So if you write, let's say, demo momentum code, and you bold this, so essentially you can also use these asterisks to bold your text. And here you see that you're not seeing the cell anymore, but you're just seeing the text. And when you click on it, you can modify this code further. You can also italicize it by removing one of the asterisks. So this is one way of using a markdown text to improve the understanding of your code. So similarly, you can also add a code cell. What would a code cell do? So here is where we start writing a code. So let me start with what we call libraries. So in Python, we have these predefined libraries. Now, what are libraries? You can think of libraries as a box of tools. You don't need to do everything from scratch. You need not go back to the Stone Age. You need not use stones and rocks to build everything from scratch. You have these ready-made tools that you can start using. So you can import those libraries and you can use the functions, ready-made functions that were already created in these libraries, and use them directly. So in order for us to calculate momentum and smoothness, we're going to use certain libraries. And certainly the most important one is Yahoo Finance. That's what I'm going to use today to download our stock data, similar to how we use Google Finance to download stock data in Google Sheets. I'm going to use Yahoo Finance here to download stock price data for in our Python notebook here. So I'm writing this code, import Y Finance. Y Finance is the library, and I'm giving that as an alias. I'm giving YF as an alias to Yahoo Finance so that I can refer to this library just by using these two letters, and I don't need to write this entire thing when I refer this library later. Similarly, I'm going to use some more libraries later. Pandas is an important library that works very well with data frames. I'm going to define later what are data frames. Data frames are table like structures. You can work on lists or tables, but here I'm going to use a lot of tables, so I need pandas as a library, and I'm also giving PD as an alias to pandas. And then I'm going to use another library or module called datetime, and within datetime I'm going to import a specific class called time delta, and I'm also going to use another class from the datetime module called date. So these are classes that I would need later to play with date variables. So if I want to add few days to something, if I want to subtract few days, I'm going to use these libraries or functions that are available in these modules. Now, once you have written this code, you can simply click on this play button that will run the cell for you, and it will show, as you can see here, there are a few things that are happening. It's connecting to a Python engine in the backend, and you can see that this code has been executed. You see a green tick mark here that tells you that this code has been executed, and it took roughly 2 seconds to run this code or execute this code. And let's say you made a mistake and you added another S to date and you try running this. You see this code has failed with an error. It says cannot import name dates from datetime. So essentially couldn't find dates as a class from datetime module. So it threw an error. So you see this warning mark saying that this cell has failed to execute. So this helps us understand if the code has executed successfully or not. So I'm going to modify this back again and run this again. So this time it ran in about 0 seconds. So in the code cell, you can also add comments saying, importing required libraries. So apart from the text cells, you can also write inline commentary to make it even more clear about how you're using this code. Now, similar to what we have done on Google Finance, let's download some price data from Yahoo Finance. To do that, let's add another code cell and let's define a variable called tickers. And I'm going to create a list and add Tata Motors as the stock or the symbol name, and we have to define them in these quotes for us to define this list. Now, one thing that you notice here is we have an extension called .ns. This is something that is required for us to download stock data or price data from Yahoo Finance. Each symbol is as an extension called .ns for NSE data and has a different extension for BSE data. So right now I'm just focused on Tata Motors, getting stock data for Tata Motors. So I'm going to define this variable as is. Now let's define a start date as a variable. And similar to what we've done in Google Sheets, I'm going to use a today function that's also available here, but it is not available as is. I'm going to use that along with the library that I have defined here. So I've already imported those libraries, so I can use that library along with that function. So date.today. So this is how you refer today function that is already present in date library. And I'm going to use time delta function to subtract 52 weeks from today. Similarly, I'm going to define end date, which is 4 weeks from today. So time delta weeks equal to 4. So you've got the start date and end date. Now you can also see the output of what you've defined by writing the variable name itself. So here you can see that start date is nothing but 25th May 2023. So now I'm going to start downloading some data into a variable called raw data. So let's define raw data as yf.download. So I'm referring finance library here, and I'm going to use download as a function. And the way we're going to use this function, it needs the following parameters. It first asks for the ticker information. So I'm going to refer to the tickers variable here. Then it asks for the time from which you need this data. So I'm going to define the start, which is mentioned in start date variable. And then I define the end, which is mentioned in my end date variable. And I would define the interval as daily. Here, you can also download weekly data, but Yahoo Finance gives us the Monday end of day prices, but we want to match this data with Yahoo Finance. So I'm going to download daily data and convert them into Friday data. So we'll see how we can do that later. Here I got the raw data. Let me just quickly run this. So you can see here that you have data from 25th May 2023. You have data for Tata Motors, the open price, the high, low, close, adjusted close, and the volume data from Yahoo Finance up until 24th of April 2024. So this entire data is stored in raw data as a data frame. Now, you can also get this data for more stocks, and you can simply add this. I've added polycap as another symbol to the stickers, and let's see what would be the output. So you can see you can get the close data for both Tata Motors and also polycap, and for all the variables. But here you can see that this data is not exactly what I need, or the format that we have here is not exactly how I want it. Because if I need to download about 100 stocks, it's going to add 100 more columns or even more than that. And it's going to be extremely difficult for us to do any kind of data analysis or data manipulation. So I need data or the stock data in rows and not as columns. So how can I really do that? So for this, I'm going to define a for loop. A for loop is something that it runs in a loop until a condition is met. So here, I'm going to define a for loop with for ticker in tickers. And I'm going to add some indentation. So indentation is extremely important when you add a for loop. Anything that is indented falls under this for loop. Anything that is not indented is outside of this for loop. So it doesn't run in that loop. So when we say for ticker in tickers, what it essentially means is that you see you have two symbols here. So it first takes Tata Motors value, it adds it here, and then it takes polycap as a value, adds it here. So it runs twice because we have two items in this list. Now that we have the for loop, instead of referring to tickers, which has both of these, I'm just going to add ticker, which is referred here. Let's see what happens now. Now you see you have the data, but I don't know to which stock does this data belong to. So I'm going to define another column here, which I call it symbol, and I add ticker to that. So the way I'm going to do that is I use this data frame that I have already created, define symbol as a column name, and ingest the value of ticker into this symbol. Now, when you run this, you'll see symbol as a column, and you see all of this data open, high, low, close for polycap defined for every day. But this is just polycap throughout. I don't have any data for Tata Motors. That is because when it runs in a loop, it first runs for Tata Motors and then it runs for polycap. And when we trying to get the output for raw data, it's just showing the data for the latest stock in this list, which is polycap. Now, if I have to get data for both Tata Motors and polycap, then I need to append this data. For this, I'm defining an empty list called stock underscore data, and I'm going to use that empty list now to append raw data into that stock data. So the way I'm writing this function is use dot append and add raw data to it. So with the first iteration, it will add Tata Motors to stock data. In the second iteration, it would add polycap to the stock data. So now let's see what happens to stock data. So if you see this, you see Tata Motors, and if you scroll further, you also see polycap. So you're seeing both Tata Motors and polycap added to this data. So when you run this, you see that this is not exactly in a data frame. It is still a list. I want to convert this into a data frame. So I'm going to use another function which will concatenate all of these lists into one data frame. So the way I'm going to define that is stock data is equal to stock data is equal to pd concat stock data. So I'm referring to a function within pandas, which I defined earlier, and converting this to a data frame. So when you run this, you can see the way it looks is different from how you see earlier. So this symbol here means, this is a table. Now you can see that date is in a different lane compared to all other variables. This is because here date is not really a variable. It's an index for this data frame. But I would like date to be another variable in this data frame so that I can use this later to do any kind of manipulation. So what I would do is I have a function called reset index, which will reset the index and add date to the table as a variable name. And I'm also adding in place equal to true, which essentially means I need to modify the same data frame and I don't want to create a new data frame here. So I'm just modifying the original data frame stock underscore data here. So in place equal to true is required. So when I run this, you can see date and all other variables are in the same plane. And the index now is actually these numbers and date is not the index anymore. And I have stock data or price data for both Tata Motors and polycap in this one data frame, which is stock underscore data. Now, at this point, I will pause the session, and I would like you guys to think about how we can derive the Friday close data. Now, what you have here is stock data for almost every day. Now, how do you get the Friday close data for every week? I think it's going to be a fun exercise. If you can think about it, write this code, and I'm going to discuss that in the next session. Thank you.